Okay, so we're going to talk about rounding a little bit here to three significant digits. So your basic rules are that if the number that you're looking at after the one you want to round to is greater than 5, you're going to round up. Smaller than 5, you're going to round down. And if it's equal to 5, then you got to do some funky stuff. So say we've got 3,924. And we want to round it to three significant digits. So we count 1, 2, 3, and this is the number that we look at. So the number, is it greater than 5 or smaller than 5? It is smaller than 5. 4 is smaller than 5. I don't know why I'm writing that down. Just so you know, 4 is smaller than 5. So that means we round down, which basically means we just pretend the 4 is not there anymore. But not entirely not there. We still have to leave a placeholder for it. So if we're going to round 3,924 down to three significant digits, it's going to be 3,920, okay? So you want to make sure you leave the 0 there because, you know, if you drop the 0, then you got 392 and right. So whenever you round down, 3,920. Now say we had 3,926. All right, we're counting to three significant digits, and so this is a 6. Our 6 is greater than 5, so we round up. And by rounding up, we mean we round this one from a 2, now becomes a 3. Okay, so the thing that was a 2 is now a 3. And then this one is going to go back to 0. So we get 3,930. The 2 goes to the 3, and everything after that becomes 0. Well, there's nothing really else after that except for that. But it just becomes a 0. Okay? So let's do a couple of more the low-hanging fruit. Let's try 49, 6, 7, 2, 8, 5. How about that one? Okay, so that ended up being 4,967,285. We are still rounding to three significant digits. So we go 1, hey, you listen to me, pen. 1, 2, 3. Okay, so this is the number that we look at. 7 is greater than 5, so we're going to round up. And we'll round up this number. So the 6 becomes a 7, and everything else becomes a 0. So whenever we round this, it becomes 497. 1, 2, 3, 4 zeros. So we still have 4,900,000 something or other, but we only care that it's 497,000. 4,970,000. There we go. But that's basically what you're doing. So if we had 8, 6, 7, whatever, 3, 2, 1, 6, 9, and we want to round off to three significant figures. Count 1, 2, 3, circle the fourth one. This 3 is less than 5, so we're going to round down. And since we're rounding down, that means that the 7 stays as a 7. Really, rounding down means you're going to keep it the way it is. And then everything else becomes a 0. So our rounded off number becomes 86,700,000. It still has three significant digits, 1, 2, 3, and everything else is 0. All right. So this even works if you've got like teeny tiny numbers. So like if I just start making up numbers again, like 8, 3, 3, 3, 2, 1, 1, and I stick some zeros in front of it like that. All right, I can still round out to three significant digits, so I just count them. None of the zeros are significant because they're at the beginning. So we go 1, 2, 3, and circle that one. Okay, 3 is again less than 5, so we're going to round down. So basically when we say I'm rounding down, what I mean is I'm taking this 33 and I'm rounding it down to a 30. So I don't know if that makes it easier to understand, but we're rounding down. The 33 rounds down to a 30, so the 3 stays the same. So the 3 stays the same and everything else becomes zeros. So what we have is 0.000833. Now what happens is, because this is a, no, see, you'd want to write all these out, right? But the problem is that since these come after the decimal point and we're doing rounding, these are no longer significant because we rounded, right? So basically any amount of significance that those had has gone away. So we get rid of those since these aren't significant anymore. So our answer is actually 0.000833. And that's pretty neat. You can round if you're going across a decimal point. So 590 blah. How about that? Like that. Again, we're going to count significant digits. 1, 2, 3. The 0 counts because it's in between numbers. So it's once we start counting significant digits, we don't stop. So 1, 2, 3, and then we look at this one. The 6 is greater than the 5, so we round up. So the 9 becomes a 10. Ooh, I was tricky. Not totally on purpose. So basically, like we said, that 96 is going to go up to 100. I don't know if that sounds weird, but we're going to round up. So this 9 becomes a 0. So in fact, instead of being 50.9, we now get 51.0 because the 9 now is a 10. And the 9 is now a 10. And all of these other things, the 0, 0, 0, whatever that they were here, all these extra zeros, they're also no longer significant. So we drop those out. And the rounded out value is actually 51.0. Now we do keep this 0. This 0 is significant. This is the one we rounded to. We want to have 1, 2, 3 significant digits. So we got that. So we want to keep it. You just need to be aware that that's what you need to do. If you're rounding from a 9 up to a 10, then you have to up the unit before it by one value. So now about where this gets kind of weird is in engineering, we get really picky about what happens if it's a 5. So say we had, all right, say we had 32.66. All right, when we looked at this kind of a problem, we're going to count our significant digits. 1, 2, 3. The 6 is greater than 5, so we're going to round up. So the 6 becomes a 7, and everything else is a 0. So our rounded off value is going to be 32.7. Again, we don't include the extra zeros anymore because they're not significant. The only reason that we keep the zeros on like over here, like these zeros, these aren't significant either. But if we drop them, significant. If we dropped them, our number would be 497, which is in no way anywhere near 4 million. So, but we still include them because if we didn't, we would change the value of our number. So again, what we're looking at is what to do when these values are exactly 5. So if we have a 32.65, okay, let's make it 653. All right, this still goes into our first category. Our first category says if it's greater than 5 or 5 plus a bunch of digits, we're going to round up. So kind of the way that they think about this is it's 5, but it's like 53, so it's like 653, I don't know. Clearly, don't you love that word? Rounds up to 7. So this is a 5. Let's count our little significant digits. 1, 2, 3. This is when we're analyzing. Since it's a 5, we open up our scope and we're going to look at that. So since it's 53, it's greater than 5. It falls into this, it's greater than just exactly 5. So it falls into this first category, greater than 5 or 5 plus more digits. So we're going to round up. So we've got the 6 becomes a 7, and everything else goes down to a 0, but we don't include them because they're no longer significant.